Thank you very much. Good morning, everyone, or good evening, depending on where you are in the world. My name is Degioanni. I am CTO and founder at Sysdig. A little bit of background on me. I started Sysdig around 6 years ago. Sysdig is my second company. My first company was called Case Technologies and was the commercial entity behind a network analyzer called Wireshark. So I've done open source and visibility and security essentially for my whole career since when I was in school. Today, we're going to talk about Kubernetes and in particular about Kubernetes security. So let's start actually from the high level before we go into the details and a little bit of, history and motivation. So we were used to run our applications in data centers, typically monolithic applications, typically providing, the hardware and the software and the operating systems for these applications. And then around 10 years ago, cloud started exploding, and Amazon started offering, AWS, and the world started really embracing it. And initially, we were mostly renting virtual machines, instances, under the form of EC2 on AWS. And then gradually, Amazon started offering more and more services. These are only examples, of course. Now there are hundreds of them. So it's really like almost like a full ecosystem. And of course, at the same time, more vendors started offering ways to deploy our applications in the cloud. Azure and Google are two examples. There are more. There's IBM, there's Oracle, there's many more. So we have at this point an ecosystem that is very powerful, very horizontal, gives us a lot of flexibility and a lot of power, and also potentially a lot of opportunities for cost optimization. But it's also relatively complex and pretty fragmented. So now, we are with the problem of having to run our applications in environments that are pretty heterogeneous. And they share some common concepts, but they have different underlying implementations. And this is where Kubernetes plays its role, right? Finally, with the new stack that is based on Kubernetes, we have essentially a common computing set of abstractions that are perfectly designed for modern cloud. And that's one of the reasons why I very often compare Kubernetes to the operating system of the cloud. And when talking about Kubernetes, I use Linux as an example. When Linux really has become, in the last 20 years, the operating system that powers pretty much everything, ranging from our cell phones to the huge machines in data centers or in cloud. Similarly, Kubernetes more and more is used as an abstraction that can really cover all of the environments that I described. This abstraction is horizontal, rich, standard, vendor independent. In particular for clouds, this is very interesting because the cloud vendors now are offering and are competing on their own implementations of Kubernetes, essentially. So not only they are embracing it, but they are actually making it part of their native offering and part of the standard way, essentially, to consume their infrastructure. But the most interesting and important, in my opinion, property of Kubernetes is the fact that it's open. As I was mentioning before, I've done open source my whole life, but it's pretty clear that when we were doing open source, 10 or 15 years ago or 20 years ago, we were starting from essentially inspiration from existing commercial applications and proprietary applications, and we were building essentially a version that was open source. Wireshark is very much like that. We were trying to get to the masses a network analyzer that would compete with the very expensive proprietary ones. Linux is an example of operating system that was inspired by Unix. Well, if you look at this wave, if you look at Kubernetes, it's very clear that this time innovation, not only in the orchestrator itself, but from the whole ecosystem is open first, and then the commercial is coming later. Let me give you some examples. Prometheus and Grafana for visibility and monitoring, open tracing and open telemetry for application tracing, Istio and Envoy that create a stack for network meshes and for networking. And for security, clearly there's a stack that is forming based on tools like Anchor, like Falco for runtime security. I'm one of the maintainers of Falco, like Open Policy Agent, OPA, like Sysdig for forensics and incident response. So all great. Well, nothing is always perfect, right? So the problem with this new stack is that there is a visibility and security gap. So containers are great, but they're also more opaque in terms of the ability to collect information inside them, especially when you're using them maybe in managed environments, like, for example, Fargate, on AWS. Kubernetes is very powerful, but everything now is orchestrated and based on microservices, which creates elements of complexity and makes it more challenging to understand what's happening. Containers have short lifespans, and that makes it hard essentially to understand exactly what's going on and collect the information that you need, especially maybe when you're doing incident response and so on from the security point of view. And it's pretty interesting to watch to look at a couple of statistics. For example, this one is from a report, the 2019 Accelerated State of DevOps, which says even the teams that are super productive, so-called elite teams that have really embraced, modern Kubernetes and microservices, tend to lag a little bit in terms of automatic security on their infrastructures. This is data that is coming actually from Sysdig 2019 and 2020 reports that show that there's still a substantial number of limitations in the security of the applications that we deploy. For example, there are still vulnerabilities in third-party libraries that are embedded in our container images, that quite a bit of containers are run with root as the user, which can have interesting long tail implications and side effects when actually deploying those containers. And very often, as I was mentioning before, since containers lifespan is so short, most of the containers have less than 5 minutes lifespan. It becomes hard to understand what's happening for incident response purposes. So from the security point of view, let's focus a little bit on the modern approach to doing security for containers, for Kubernetes, and for microservices. When presenting this, I like to use this diagram that shows the phases in the life cycle of an application: build, run, and respond. Very much and more security needs to match these different levels, needs to adapt to these different levels, and need to be able to essentially follow these ages in the life of an application in a way that is as automated, as powerful, and as standard oriented as possible. From the build phase on the left, build is really the area where we have an opportunity to shift security left. And this is very, very important and very exciting, right? So technologies like image scanning and vulnerability scanning, or the ability to do strict validation of configuration and dependencies of applications as they travel through the CI/CD pipeline is something that is extremely important and must be part of a modern security strategy. And of course, we'll talk a little bit about that later, but of course, you want to cover this in a way that is as comprehensive and granular as possible, because there are many opportunities of integration in the CI/CD pipeline. But at the same time, at a certain point, applications need to go into production. So at that point, we need to make sure that we have a good posture in terms of runtime security, in terms of network security and segmentation, in terms of monitoring and collecting the right data to be able to understand not only the health, but the security of our applications as they run in our environments, any kind of environment, and data center, cloud, anywhere. And then, of course, as I was saying, containers and services tend to have relatively short lifespans. So there is a very important response phase, which is very different nowadays, because traditionally we just used to go into a machine when we wanted to do incident response, and we would expect the machine to still be there and have all of the tools that we needed. That's not the case anymore. So understanding in an environment like this how to do incident response, how to do forensics, how to do troubleshooting becomes challenging, different, and particularly important, because otherwise we are really left with problems when something happens and we don't really know what to do. Compliance sort of becomes an encompassing sort of area that starts from build and goes down to the right and respond. PCI, NIST, CIS, and all of the standards. From one point of view, it's very clear by talking, to many users and many customers that more and more, in the modern cloud, being able to be compliant is of key importance. But again, there's not a specific way to do that. Compliance needs essentially to put together the whole story, the whole life cycle, in a way that is consistent and comprehensive to actually be effective. So now, with this framework in mind, let's take a look at some principles. Essentially, this is just a few things that I came up by translating into slides my experience as both an operator in the space and somebody who, as the founder of one of the key companies in container security, is witnessing essentially by talking to users, customers, adopters, both open source, because I'm also one of the original creators of Falco, the runtime security tool for Kubernetes, and commercial. So the principles that I want to discuss today are 6. Number 1, security belongs in the pipeline. Number 2, verify workloads before deployment. Number 3, context is king. Number 4, prevention needs to be better is included. Number 5, make sure to secure the whole stack. And number 6, have a plan for when shit is the fan. All right, let's start from the pipeline. And we talked already a little bit about how it is important to shift security left and to make sure that our code, our applications, our containers, our images are safe by the time they go into production. And that can be done by embedding image scanning in the pipeline in different places. First of all, starting as soon as possible. Typically, nowadays, it's good practice to have scanning embedded when building your software. So Jenkins integration and plugins are something that most of the scanning technologies, both open source and commercial, offer, and it's really important to take advantage of them. So not only we can block automatically code and images that have something that we don't want them to have, but we can also do that in a way that gives feedback to the developers. The feedback loop is very important because security for developers can be completely disruptive and annoying, which is what they are traditionally conditioned to think, but can actually be, let's say, a way for them to be more productive, assuming that the feedback comes at the proper time, and maybe when possible, the fixes are automated for them instead of just require them to do changes. There's, of course, other opportunities to do image scanning that range from admission controllers and essentially being able to block the images before they go into production, to be able to do that on registries. And one thing that I see many people doing is just maybe scan the images before they go into their registry and repositories and be good with it. Well, you know, new CVEs come out all the time. So new vulnerabilities are discovered, the ecosystem is changing, critical stuff gets, you know, exposed by the community and by the researcher. So if we don't keep scanning images as they are in our repositories, or even as they are deployed in production, these images will age. The code in these images will age. The dependencies in these images will age, and the security profile will change. So we need to make sure that we are, of course, very diligent in blocking stuff before it goes into our registries, before it goes into production. But we also want to be diligent on just continuing, taking a look at our images as they are sitting in a registry, as they are deployed, so that we can prevent them from running or block them if they're already running when we discover something new. Talking about going into production, yeah, it's important that features of the orchestrator, like for example, the admission controller in Kubernetes, are leveraged as much as possible. The admission controller allows us to take essentially decisions on what goes into the Kubernetes cluster and potentially block stuff that is not conformant to our decisions. And one of the cool things about the admission controller is that we can apply more logic based on, for example, the service, the cluster details, and not only on the image levels. Very often, and it's common, things will have different profiles depending on what they are and where they run. A development cluster has naturally a different profile than a production cluster that maybe contains sensitive information. So the admission controller and plugging image scanning into that admission controller allows us essentially to have this kind of granularity and treat these environments which require different treatments in different ways. Another lesson, context is king. What do I mean by context here? Context is the ability to take information coming from your Kubernetes clusters. Information can be security events, can be metrics, can be forensics information, anything, and enrich it by talking to APIs like the Kubernetes API in terms of orchestrators, container runtime like Docker, cloud APIs, AWS, Azure, GKE, consuming labels, all of this kind of stuff, and converting this information in a way that makes more sense because it's enriched by the context. For example, here in this slide, we have a bunch of physical machines, and for the sake of just simplicity, every machine is running 4 containers, and we have color coding here based on the service these containers belong to. Typically, you don't want to do security based on what's depicted on the side of the slide. You're more interested in doing it based on how the right side of the slide is depicting. So on a service by service basis. When you define a policy, you want to do it, for a service, not for a set of containers that are running on the host. When you're receiving information about your cluster, or you're doing, like forensics analysis, typically you want to go and investigate and make comparisons about the different containers that are sitting on a on maybe different hosts. And as a user, you want to approach things like this, but in practice, physically, it will be like this. So you need essentially your tools to be able to understand essentially this layer and make sure that, for example, when you apply a policy only for the yellow stuff, finds the yellow stuff and applies it for you. Why is context so important? Why is going from a security event that just tells you, somebody has executed a shell in one of your containers into, all of the richness of the metadata so important? Well, let me use an example, a metaphor for this. Suppose, you are an investigator and you are in charge of solving a crime. For example, a robbery. A naked security event without context is like a little bit like a snapshot from a security camera, right? So yeah, a tool like, for example, Falco, which can do runtime detection for Kubernetes, can tell you essentially, somebody did something bad, can give you like a small snapshot. And the snapshot is useful, at least that something bad has happened and you can get a rough idea of what it was. But imagine you could convert these into information about the person that did this, exact, mapping details about where this happened and what time maybe, and all of the details about the location. Information about what exactly was stolen and the details about that. Maybe the names and the addresses of people who owned the stuff that was stolen. How easy would it be to solve this issue and essentially return the stolen stuff if you had all of this information instead of just the security camera information? Well, is something like the enrichment that is done by tools like Sysdig can start from an information just like, a sensitive file was read in your infrastructure, which is definitely useful by itself, but it can convert it into, details about the file, the process that touched this file, the name of the user, the team this user belongs to, the environment, production versus development, and so on, the data center, the container image, and as a consequence, information about what particular piece of software essentially caused this. Kubernetes information like the pod, deployment, namespace, cluster, and so on. The beauty of standardizing on Kubernetes is that it's all based, especially when you're running it on the cloud, it's all based on APIs. So this is all information that if your tools are smart enough, they can go fetch automatically for you. This is interesting because, for example, I was talking recently to a customer of Sysdig, which is a big financial organization, and they were telling us traditionally, in order to go from the left to the right of the screen, they were receiving an event, and if the event was interesting enough, they had a team with a set of scripts, and they were going to this team and tell them, run the scripts and essentially enrich the event with all of the information on the right. Now with Sysdig, and thanks to the power of Kubernetes, these can be done completely automatically, and every event already comes with all of this information. And this not only saves a lot of time, but makes it possible to have investigations that you couldn't have before. So that's why context is so important. Another lesson, prevention and batteries included for prevention. This is one that I tend to be very opinionated about, and Sysdig as a company tends to be very opinionated about. Kubernetes comes with a lot of powerful pieces of functionality that are already part of the platform. I mentioned that mission controller a couple of slides before. So a piece of functionality in Kubernetes that allows you, based on arbitrary rules and policies, block images from and containers to being executed in Kubernetes clusters, but also network policies, which is a generic plugin based framework for layer 3 segmentation on Kubernetes. IAM roles, AppArmor profiles for essentially being able to reduce the surface of what containers do. SecComp, similarly, pod security policies, service meshes, like for example, Istio. All of these are components that come pretty much pre-packaged in Kubernetes. And doing security in Kubernetes is very much a matter of leveraging these components that are already there, instead of reinventing, I don't know, segmentation for Kubernetes, or reinventing filtering and surface attack area decrease in Kubernetes. Traditional vendors tend to come to new generations of infrastructures with the mindset of, okay, let's recycle what we had before and let's try to apply it to the new world. Typically, that doesn't work. So be wary of, I don't know, somebody that comes and tells you they have their own customized implementation of segmentation, network segmentation for Kubernetes. That will be not only less efficient, because it will require essentially a separate mechanism that you need to put on top of what Kubernetes already offers, and as a consequence, generating overhead. But it will also be less effective, because Istio and Kubernetes network policies come essentially better tested by the community in terms of functionality, in terms of richness, in terms of power, and in terms of scale. And reinventing it, even if the vendor, is a very reliable vendor, won't bring the same results. At the same time, it's very important for vendors to complement these kind of technologies, because network policies are a great underlying mechanism to implement microsegmentation on Kubernetes. But still, you have a complex environment based on services where just understanding what should talk to what becomes a challenge. So the vendor should help you with that, defining your policies, supporting you in understanding what's normal, automating and scripting the usage of all of these pieces of batteries included functionality, which could be complicated, rather than reinventing them. So the vendors should sit a layer on top of this instead of at a layer where they want to reinvent this. Secure the whole stack. If we go back to the build, run, respond diagram, it's very important, as I was saying, to cover essentially in a vertical way all of these areas. But in practice, our applications will be running in the different phases on machines that can be running in your data center, in the cloud provider, that can have different operating systems, that can have different stacks, that can be automated in different ways. So even if it's very important to secure the containers, to secure the CI/CD pipeline, to do image scanning, to do runtime security with tools like Falco, it's equally important to make sure that the underlying infrastructure, hosts, the way we use cloud, access to our consoles, and so on, are secured in the same way, because security, it's a chain, and the chain is only as strong as the weakest link in the chain. So making sure that we still do host level security, making sure that we do cloud level security by keeping an eye on who's using our cloud, what operations are done, by being able to lock nicely what's happening on the machines is as important as doing the sophisticated stuff of protecting our containers, doing network meshes, and so on. So don't forget essentially the basics only because we have fancy stuff like Kubernetes. The basics keep remaining as important as they were before. In addition to that, we need to make sure that we also have the more sophisticated stuff for our containers on top of that. Last one of my lessons learned is again, in a diagram like this, the respawn phase, right? You need to be ready. Shit will hit the fan at a certain point. And when that happens, don't be caught with your pants down. Have a strategy for how you're collecting data for forensics capabilities. Have a strategy on how you are generating your audit logs. Have a strategy. I come from the packets world. I come from Wireshark. So actually, one thing that I've embedded in the work that I've been doing with Sysdig and with Kubernetes is the ability to take captures. For example, the screenshots on this slide is Sysdig Inspect, an open source tool that I recommend you to go and take a look, that allows you essentially to take captures and analyze these captures for your containers and your Kubernetes environments and do investigation. This is one example of tools that you can use, but it's very important. Again, as I was saying before, you won't be able to SSH into your machine anymore if you get a red blinking light from your security tools, because the machine is not going to be there anymore, or better, the container that was including your code won't be there anymore. By the time you get the blinking red light, you are almost guaranteed that Kubernetes will have orchestrated away the container where you could have done, or the pod where you could have done your investigation, right? So data needs to be collected before, because otherwise you will be completely blind. You won't be able to understand the blast radius. You won't be able to understand if somebody actually stole data and what data it was. So this is something that you need to plan before as part of your strategy, and not only when the red light starts blinking. Otherwise, it will definitely be too late. All right. Before I close my presentation and maybe I open this up to questions, I just want to give you some links. This is the blog where you find a lot of information, and the falco.org is where you can download Falco. Falco is really the de facto runtime security tool for your Kubernetes environments. So please go take a look. I'm one of the maintainers of Falco. Sysdig also has several ecosystem security guides. So please come to our website and take a look. And also we have a trial of our Sysdig Secure product that you can come and you can, for 30 days, you can use it on your environment. This is the link to do that. Talking about Sysdig Secure, of course, I just want to, spend a minute to advertise what Sysdig is doing at the conference. We have another couple of talks, one later today from Chris Nova, and the other one tomorrow from Aaron Newcomb. They are all very interesting and practical. So please, go and follow them. And of course, Sysdig has demos that you can go to essentially look, more like in practice from a security point of view, how the guidelines that I describe can essentially play a role. So please come, and say hi. We would be very happy to talk to you. That said, let me stop sharing And let me just see if there's any questions from the audience. The first one is, I see a couple of questions in the chat. One is, are the slides going to be shared? Yes, I believe so. I think that, yeah, all of the slides will be shared, and maybe at the end of the presentation, I see that Ella, you're still there. You can give details to the audience about that.
Yes, the presentation will be shared. We'll have these available.
Perfect. Another question from Matt is, do I also need to be aware of the cost involved when things are scaled? Is there a view for that to report to management? Yes, scalability is a key factor in all of these. As Kubernetes is becoming more and more mainstream, clearly it's interesting because especially this year, I am seeing more and more, almost exponential number of deployments that are really in production at scale. Up to, let's say, 2018, 2019, I was seeing mostly smallish deployments and more like in development environments. While now Kubernetes in production is definitely exploding. And it's interesting because many of these technologies really need to work not only, you know, for like 50 containers, but they need to be able to run for 50,000, 500,000 containers. This is the kind of stuff that I'm seeing. So definitely things become potentially more expensive when you have huge infrastructures and deployments. But I would say there's also ways to mitigate the costs. One thing that is nice about Kubernetes, I was saying, is that a lot of stuff is better is included. So up to a certain level, it's really doable to have a completely or almost completely open source stack for Kubernetes. Beyond a certain level, it is good to rely on vendors. And it's important to understand, for example, one thing that I'm talking about Sysdig specifically here, but one thing that we have in our model in terms of offering our product to our users is make it charge based on number of machines and not on number of containers, so that you can essentially have a higher density of containers in a single machine and essentially make this more cost effective. This is something that I've seen done many times. Essentially, when you get serious about Kubernetes, you start packing many containers inside very beefy machines that allow you to optimize the cost, both in terms of, you know, hardware or cloud costs, and also in terms of overhead, in terms of instrumentation, overhead in terms of like a vendor deployment and complexity and all of this kind of stuff. And you can pack, I've seen, you know, users pack hundreds, sometimes several hundreds of containers in single beefy machines, and then essentially let Kubernetes do the job of orchestrating all of this stuff in the proper way. And Sysdig as a model, essentially, it instruments the underlying operating system using eBPF instead of instrumenting every single container. This means that the bigger the machine you have, the more containers you can pack, the smaller the relative overhead of Sysdig becomes on that machine, and the more essentially you can relatively contain the costs of deploying essentially security through Sysdig. This model is opposed to maybe having like security implementing through sidecars, for example, running in pods inside Kubernetes, where the overhead essentially at that point is linear based on the number of containers. So there are a little less benefits when you're scaling your infrastructure. So even just the way you structure your stuff and you architect essentially your clusters can have an impact on cost when you're scaling and scaling a lot. Any other questions? I don't see any at this point. Let me maybe just wait another 30 seconds in case somebody has one. If not, I just want to thank you, everybody in the audience, for being with me for these 40 minutes. And again, you know, Sysdig is around. Please come. Oh, actually, there's one. Do you have any other suggested resources to gaining experience with Kubernetes? There's quite a bit of stuff around. Kubernetes definitely is not the, let's say, easiest thing to get acquainted with. But I was saying, I see that one of the attendees has suggested some links. So those are definitely great. In particular, those are related to OpenShift with Red Hat, which is definitely a great way to deploy Kubernetes. The Sysdig website contains several resources to start with Kubernetes. Kubernetes.org, the organization, has a great set of documentations and links, and also a set of blog posts. So, and one place where I love going, honestly, is the Slack. So if you go to the Kubernetes Slack, there's a ton of people. There's always lively discussion, and there's always somebody that is willing to essentially help answer your questions and give you some pointers. And as I was saying, for sure, you know, if you go to sysdig.com, we also have resources. The great thing about Kubernetes is it's completely community oriented. So it's really like Linux, you know, you will find a lot of stuff. All right, let me close it here. Again, thank you very much for attending. See you guys around, and have a great rest of your day, and have a great rest of the conference.